Hi students, welcome to ACE Academy. Today we are going to discuss about some of the important questions which concerns to physics. So in previous class we already discussed about how many questions we will expect from general science. So we are mostly we are getting around 6 questions, minimum 6 questions. Na? So from physics, physics, chemistry, biology. So from these 3 subjects, you will get minimum 6 questions. Okay. So suppose if you consider CHSL examination, so on an average you will get 6 to 10 questions. Okay. So that much importance majorly we observed from this general science point of view. Okay. So today we are going to discuss about some of the important questions which concerns to physics. So what kind of questions are majorly mentioned in your previous year examinations? Okay, so how we will expect few questions which concerns to physics point of view, especially in CGL, SSC CGL Tier 1. Okay, yes. So here it is, the first question. Force of attraction between molecules of the same substance is called. Okay, I will give you 10 seconds for 10 seconds. So you have to select the right answer. The force of attraction between molecules of the same substance is called dash. Option A, option 1, viscosity. Next, cohesive forces. Next, surface tension. Next, adhesive forces. Which is the correct answer here? Yes, which is the correct answer here? So if you observe the question, force of attraction between molecules of the same substance. Okay, so those type of forces are called as cohesive forces. For example, if you consider fluids, okay, so fluids, mostly liquids, at the same time gases. These two are considered as fluids, liquids and gases. Actually, these two are not having particular shape. Next, it always flows from high temperature region to low temperature region. Okay, it always flows from high temperature region to low temperature region. Next, high pressure region to low pressure region. So it does not having specific volume. Okay, so specific structure like that. Okay, so that's fine. These are all considered under the category of fluids. So finally, if you consider fluids, actually it has two types of forces. Two types of forces. So first one is cohesive force. Okay, first one is cohesive force, and second one is adhesive forces. Okay, nothing but adhesive forces. Okay, what is meant by cohesive force? Cohesive force means attraction lies between same kind of molecules, or attraction between molecules of the same substance. Okay, for example, if you consider water, okay, here it is water. So water is water. If you consider any water drop, mostly it exhibits spherical shape, because of surface tension phenomena. So how to explain the spherical geometry of water molecule? Okay, so here guys, here in this drop we are having only H2O particles. Okay, H2O particles. Next, H2O particles. Same kind of molecules are there, na? So in between same kind of molecules, what kind of forces we have? Cohesive forces. Okay, so if cohesive forces are increases, then surface tension increases. Next, the size of the molecule, size of the liquid mostly be decreases. Size of the liquid mostly decreases. Okay, so this is the conclusion. If cohesive forces increases, size will be reduced because of surface tension is increases. No? So this is about cohesive force. And next, if you consider adhesive force means attraction lies in between different molecules. For example, here it is water, H2O, and here it is some hydrocarbons. Okay, nothing but kerosene like that. some hydrocarbon molecules are there. So in between these two particles, what kind of forces will be existed? Adhesive forces. Okay, why? Because these are not same molecules, na? Same kind of particles. Na? These are not considered as same kind of particles. Due to that, we are considering this is nothing but adhesive force. In these two things, which is the major, which is considered as the strongest one? Cohesive force is always stronger than the adhesive force. Okay, so final conclusion, cohesive force is the correct answer here because of same substance. Next, viscosity. Viscosity means nothing but the resistance of flowness of liquids. Okay, the resistance of flowness of liquids. For example, if you consider honey and water. So if you poured some honey molecules on the surface, okay, if you poured on the surface, then what will happen? Here, these molecules are move very slowly. Na? Next, suppose if you consider water, so these molecules flows very faster than the honey particles. The reason is, honey is having, if you consider honey, in between any two layers of honey, it has very strong forces, okay, because of the existence of those cohesive forces, it impacts on the flowness of the liquid. Okay, the resistance of flowness of liquid is nothing but viscosity. Okay, next one, surface tension. Surface tension means if you consider any liquid, mostly it tries to reduce the size. Okay, it tries to reduce the size because it has cohesive forces. Okay, suppose if you consider same kind of particles, in between those molecules, what kind of forces we have? Only cohesive forces. Na? So because of that, initially the size of the particle is like this. Okay, size of the liquid drops are like this. After it maintains the surface tension phenomena, then the size of the molecules exhibit like this. Okay, here size is completely reduced. So it means simply we consider surface tension means nothing but it purely concerns to the size of the drop. Next one, adhesive force. Of course, we know that these are the remaining options. So here the correct option is option 2. Okay, next. Next question, who among the following is credited with postulating 3 laws of planetary motion? Here it is the options, Galileo, next one Newton, next Kepler, next Tycho Brahe. So which is the correct option here? Yes, guys, which is the correct option here? Okay. Kepler law. Sorry, here it is 3 laws of planetary motion. Suppose if they mention this terminology, you have to consider Kepler laws. Okay, so Kepler laws. So suppose if you consider solar system, in that sun is existed at the center. Na? Next, all the planets, actually we have 8 planets. So all the planets revolving around the sun in elliptical orbit. Okay, next, so here first planet is Venus, next Mercury, next Earth, next Mars, okay, next Jupiter, so Saturn. So number of planets we have now, totally 8 planets we have now. Here the distance between planets is also being increased. Okay, suppose if distance increase, then the time taken to complete one rotation is also being increased. So finally what I'm saying is, if you consider laws of planetary motion, yes, so here 3 laws we have. So first law, actually these laws were proposed by Kepler. Okay, so first law is nothing but law of orbit. Yes. So what is the major objective in law of orbit? So if you consider any planet, okay, it revolves around the sun. It revolves around the sun in elliptical orbit. So sun is situated as one of the focus of the ellipse. So this is nothing but law of orbit. Okay, so every planet is having a specific orbit. That is nothing but law of orbit. Next, second law. So this is first law. Simply it is also called as law of orbit. Next, second law. Second law is considered as law of areas. Law of areas. Law of areas. So what is meant by, what is the major postulate in law of area? Here, suppose if you consider a planet, okay, so to cover the distance, so these are the 2 points, let's consider, here it is A and here it is B, and here it is C and here it is D. Okay, so here the distance is same. To cover the same distance of the orbit, it takes same time. So that is nothing but law of areas. Okay, to cover the same area, it takes same time. So that is nothing but law of area. Law of area. So here it is the concept: the planet and the sun swept equal area in equal interval of time. Equal interval of time. So this is nothing but law of areas. Okay. Next, third law. Third law. So this third law simply pronounced as law of periods. Law of periods. Law of periods. Okay, so what is the meaning of law of periods? Simply you have to remember like this. Suppose if you consider the solar system, so totally 8 planets we have now. So to complete one rotation of Venus, okay, so next to complete one revolution, so sorry, not rotation, revolution. Okay, why? Because it revolves around the sun. Yes, so that's why we have to use the terminology revolution. So to complete one revolution around the sun, so mostly Neptune takes maximum time. Maximum time. Why? Because if the radius increases, time period is also being increased. Okay, so this is nothing but law of periods. Okay, so here it is the concept. So the square of time period, t square, is directly proportional to r cube. Here r means nothing but radius. So in between the distance between sun and the planet. Next, t means nothing but time period. Okay, if radius increases, mostly time period is also be increased. So here this is the relation between those two things. So final conclusion: who was proposed planetary motions? Nothing but Kepler. Okay, we have heliocentric theory. Next, geocentric theory. Okay, so this theory proposed by whom? This type of concepts are also be important for your examination. You may have an idea about Ptolemy. Okay, so Ptolemy. Right, at the same time Tycho Brahe. Next, Newton's Galileo. Galileo proposed G value. Galileo proposed his concepts are majorly related to G value. At the same time, the first thermometer. Okay, the first thermometer was developed by Galileo. Of course, in that he used water as the thermal conductor. Okay. Next, Newton's. So suppose if you consider Newton's, we have law of motions. Okay, so those motions laws were proposed by Newton's, and G value was first. The concept gravity was proposed by Sir Isaac Newton. Okay, next, Tycho Brahe. He is also one of the greatest philosopher. So these are the concepts about remaining concepts or remaining options. So the next one is: with what do you divide thrust in a liquid to obtain the value of pressure? Okay, so here it is the direct formula based question. So these are the options: density, mass, volume, and next area. Okay, so what did they mention? What do you divide thrust in a liquid to obtain the value of pressure? So simply they raised, what is the formula of pressure? Okay. What is the formula of pressure? Yes, so pressure P is equal to thrust by area. Yes, that's why we have to consider option 4 is the right answer. Option 4. So what are the units? Suppose if you consider CGS. In CGS, so thrust means nothing but that is also one of the force. So that's why we have to consider dyne. Area means centimeter into centimeter. Okay, so volume into length into breadth, L into B. So that's why we have to consider centimeter into centimeter, centimeter square. Suppose if you consider SI units, then thrust here Newton per area. Area means nothing but meter square. So this is nothing but Pascal. This is nothing but Pascal. Newton per meter square is considered as Pascal. So these are all units of pressure. Units of pressure. Okay. So we also know that 760 centimeters. If you consider 1 atmosphere is equal to 76 centimeters. Okay, or 760 millimeters. 760 millimeters. Suppose at the same time 760 torr 760 torr like that, and we are also having Barna. So those are all considered as some of the units of pressure. So here in examination point of view, so mostly you will get very simple questions, okay, just like units, at the same time formula based questions. So you have to remember the units of pressure also. Okay, so here one more interesting point is, if you consider pressure, is it vector quantity or scalar quantity? Pressure is always considered as scalar quantity. Okay, so scalar quantity. Scalar quantity. Why? Because it depends only on magnitude. Magnitude. It does not depends on direction. So that's why we have to consider pressure is pressure is scalar quantity. So density is also like that, mass is also like that, volume. So these are all considered under the same category. So next, okay, here it is. So pressure is equal to thrust by area. So pressure is always considered as scalar quantity, and you have to remember the units also. Next, next question. An elastic wave generated by an impulse such as earthquake or an explosion is called. An explosion is called. So here, which is the correct option? Yes, guys, which is the correct option? Okay, so 2, sound wave. Right. So tectonic shift, second one sound wave, third one seismic wave, fourth one epicenter. First of all, if you consider an elastic wave generated by impulse such as earthquake is generally considered as seismic wave. Okay, so seismic wave. So we have to use Richter scale to identify the impact of earthquake. Okay, so how much impact is majorly created by those regions which was caused by earthquake. Okay, so for this we have to use a Richter scale. Yes, so and here we are getting seismic waves. Okay, option 3 is the right answer. So what about the remaining concepts? Here it is. So seismic wave is nothing but radiates from the focus of the earthquake. Okay, so suppose here it is. Here it happened some earthquake. So then mostly we are getting some waves. So those are nothing but seismic waves. Na? So where the earthquake is generated, that point is considered as focus. Suppose here it is the focus. So if you draw an imaginary line just like this, okay, which is perpendicular to the focus, so then that one is considered like epicenter. Epicenter, okay. So tectonic shift, so this is the meaning about epicenter. And sound wave, we already know that sound is nothing but a mechanical wave. Okay, so it requires medium to propagate energy. Okay, so it requires medium. Next, tectonic shift. Tectonic shift means nothing but the movement of the plates that makes up earth crust. Okay, so if you consider earth crust, actually to form this earth crust, around 12 plates were involved to form the earth crust, approximately 12 plates like that. So the movement of those plates, then finally we are getting the earth crust like that. Okay, so because of the movement of the plates, we are getting earthquake like that. So finally, so that is nothing but tectonic shift. Tectonic shift, nothing but the movement of the plates. Movement of the plates. So these are the meanings of the remaining options. So here the correct option is option 3, seismic wave. Right. So here it is the concept. Of course, we know that. What is the meaning of focus and epicenter? Epicenter is a point directly above the focus on the surface is epicenter. Next question. For a wave, wavelength divided by the time period is equal to phase difference, next wave velocity, next frequency, next amplitude. So which is the correct option here? Which is the correct option here? Yes. Suppose guys, if you consider a wave, actually here it is having crest and trough. So crest, trough. The distance between any two successive crests is considered like lambda. Here also same. The distance between any two successive crest or trough is considered like lambda. Lambda is nothing but wavelength. This is wavelength. Wavelength. Next, amplitude. Amplitude means the maximum displacement of a vibrating particle from its mean position is nothing but amplitude. So this is the maximum displacement. So this is considered like amplitude, simply indicates with small a. Next, frequency. Frequency means the number of waves per second or number of oscillations per second is considered as frequency. Okay, so next, phase difference and wave velocity. So suppose if you consider phase difference, so phase difference means the difference in the phase angle of the two waves. Suppose if you consider waves like this, okay, this is one wave and this is second wave. Okay, so here the angle between, okay, the phase angle difference between these two waves is considered like phase difference. And the next one is wave velocity. Okay, wave velocity. Here, wave velocity means, suppose if you consider a wave here, okay, so this is one wave now, one wave. So here it is having one crest and one trough. So one crest and one trough is considered like one wave. So here what did they mention? For a wave, wavelength is divided by the time period of a time period is equal to. So that is nothing but wave speed. Here it is the definition. The speed of wave is equal to the wavelength divided by period or to frequency multiplied by wavelength is considered like wave speed. Na? So this is the direct statement. So due to that, here we have to consider option 2 is the right answer. So you should also remember V is equal to F into lambda, where V is equal to velocity of the sound and F is equal to frequency and lambda is equal to wavelength. Okay. So finally we have to consider option 2 is the right answer. Option 2. So next one. What is represented by the product of force with the displacement in the direction of force? Okay, what is represented by the product of force with the displacement in the direction of force? Here they mention 4 options. So which is the correct option here? Okay, which is the correct option? The product of force and displacement. Force and displacement. It means F into force means nothing but F, na? Displacement is considered like S. Okay, F into S, that is nothing but work. Nothing but work. So that's why we have to consider option 2 is the right answer. Option 2, work is the right option here. And we are also having W is equal to Fs cos theta. Fs cos theta. Suppose if theta is equal to 0 or if theta is equal to 90, then we can estimate if the work is done or not. Okay, so it depends upon the angle, nothing but theta. Right, so next, impulse. Actually, impulse impulse is derived from the phenomena of Newton's second law. So I is equal to, impulse I is equal to F into, so T, okay. I is equal to impulse, already we know that F is equal to ma, na? So mass into acceleration, so delta T. So here it can also represented like A means change in velocity by change in time. Okay, so here it is time. So if you cancel these two things, finally what we get? So m into delta V. Nothing but I is equal to m into V means nothing but momentum P. Na? So momentum means Mass into velocity. Mass into velocity. Of course, we know the definition of power. So power means nothing but work per particular time. No? Yes. So finally, here the correct option is option 2, work. Right. Next question, which of the following is one of the main cause of tides? Yes. So this is the most important concept. We already discussed in the last class. Yes. Which of the following is one of the main causes of tides? How tides will be generated on this planet? Which is the major responsible one? Yes. So gravitation pull of the sun and the moon. Next, closed orbit of planets. Next, rotation of Earth. Next is solar flares. So which is the correct option here? Yes. Suppose if you consider tides on Earth, the major responsible one is moon and sun. Okay, majorly that credit goes to moon. So if you consider Earth, its G value 9.81 meter per second square. 9.81 meter per second square. Next, if you consider moon, its G value 1.64 meter per second square. Next, if you consider sun, its G value is 27 times of Earth G value. 27 times of Earth G value. Okay, so that much gravity it has. Due to that, all the planets which are existed in this solar system revolving around the sun is the major reason is its gravity. Sun's gravity. Sun is having highest gravity. Na? So finally what I am saying is, if you consider moon, actually if you consider moon and Earth is looking like spherical, na? But because of the effect of moon's gravity and sun's gravity, it's looking like this. It means the orientation of the planet is looking like this, just like elliptical. Okay, elliptical. So because of that, here this one is considered like high tide, and this one is considered like low tide. Okay, low tide, and this is high tide. So here also same, low tide, and here it is high tide. So this is caused by moon and sun's gravity. So that's why we have to consider option 1 is the right answer. Option 1 is the right answer. Okay, right. So next one. So rotation of Earth is not considered. Solar flares are also not responsible for the formation of tides. Next, closed orbits of the planet. So closed orbits of planets is not responsible for formation of tides. Why? Because it does not having that much of gravity. Okay, and one more interesting point, the distance between those planets is also be far. So due to that, we should not consider remaining options. Okay. Yes, the next one is, who among the following was the first to conclude that in vacuum all objects fall with the same acceleration g, and reach the ground at the same time. Yes, of course, you know the concept of Pisa Tower. Suppose if you drop any two objects, okay, just like here, let's consider these two objects. So this one is having a higher mass compared with this one. But if you drop these two objects from Pisa Tower, so almost it takes same time. Why? Because in that region, mostly atmospheric gases does not impacts on the flowness of or the speed of these two objects. Okay, and one more interesting concept is G value would be very somewhat less in that region. So due to that, so we have to consider same two objects are having. If you consider different masses, even though two objects are having two objects reaches the same time, because less impacts on the atmospheric gases and G value also. So this concept was proposed by Galileo. Option 2 is the right answer. Okay, option 2. Of course, remaining options Albert Einstein. So relative theory E is equal to mc square, and photoelectric effect photoelectric effect. These were proposed by Albert Einstein. So for this concept, photoelectric effect, he received Nobel Prize. Okay. Next, and Thomas Alva Edison, electric bulb. Bulb was discovered by Thomas Alva Edison. Okay. And kinetography. Kinetography concept was also introduced by Thomas Alva Edison. Next, Newton's. Okay, we already know that Newton's first law, second law, third law, Newton law of motions. Okay, next, gravity. The term gravity was first introduced by Newton. So these are the some of the important concepts which concerns to the remaining legendary persons. Okay, right. So next one, how many microns are there in a meter? So it is very simple question. How many microns are there in a meter? Of course, 1 micron is equal to 10 power minus 6 meters. No? So this micron, the term micron is especially used to indicate the thickness of materials. Thickness of materials like plastic materials. So 75 microns, 50 microns, 100 microns. This terminology actually we used in our surroundings, right? So finally here they mention how many microns are there in a meter. Okay, 1 micron is equal to 10 power minus 6, nothing but 1 by 10 power 6 meters. So in 1 meter, how many microns are existed? Suppose if it comes here, then what we get? 10 power 6, na? 10 power 6 means nothing but option 2 is the right answer. Option 2. This is the right answer. Next, dash is the external agency applied on the body to change its state of rest or uniform motion. So it's purely concerns to Newton's laws. Of course, we know that Newton's first law, next second law, so third law. Newton's first law indicates inertia. Suppose if you consider Newton's first law, it majorly indicates about inertia. So actually, the concept of inertia is considered in three orientation, or here three types of inertia forces are there. Okay, inertias are there. So those are considered like motion of inertia. Next, direction of inertia. Next, rest of inertia, or inertia of rest, whatever it is. So totally we have three constraints, especially in an inertia point of view. So what is meant by inertia? Without applying of any external force, the object mostly exhibit in the same position. Okay, so there is no change in its position without applying of any external force. So that is nothing but first law, Newton's first law. Next, if you consider Newton's second law, it discusses about F is equal to ma. F is equal to ma. Force is equal to mass into acceleration. And in this second law, we have a law of conservation of inertia. Okay, so law of conservation of moment, this type of terminology, and impulse, these are all considered as some of the applications of or some of the proposals or some of the concepts which are derived from Newton's second law. Next, Newton's third law. Here, for every action there is equal and opposite reaction. Okay, equal and opposite reaction. Suppose if action is one direction and reaction is completely opposite to that direction. So finally what I am saying is, suppose if you consider Newton's first law, in that they proposed what is the meaning of force. Okay, here they proposed the meaning of force. Next, Newton's second law. So how much force is needed to change the position of the objects. Next, Newton's third law. So in that they mention in this universe, so single force is not existed. Okay, so we always having these type of forces. Suppose if one force is in this direction, okay, so in clockwise direction, automatically in anti-clockwise direction another force will be developed. Okay, so that is nothing but action and reaction. So these are the terminology which were mentioned by Newton's in his laws. Okay, so here for this you have to consider force. Option 1 is the right answer. Force is the external agency applied on the body to change its state of rest or uniform motion. Uniform motion, here it is the laws of motions. Na? So first law and second law and third law. Okay, right. Next one. Which of the following statement is correct? Which of the following statement is correct? Yes, so here they mentioned, yes guys, which of the following statement is correct? So here they mentioned two magnetic field lines may intersect. Next, the net magnetic flux through any closed surface is 0. Next, earth magnetic poles coincide with the geographic poles. Next, magnetic flux is a vector quantity. So here they mentioned about the correct statement. Na? So here it is the magnetic flux. Suppose if you consider a magnet, it has lines just like this. So if you consider any two lines, mostly those two are not intersect. Na? So that's why here, if you consider the statement, magnetic flux is vector quantity. Actually, magnetic flux is not considered as vector quantity. It is a scalar quantity. Okay, so that's why option 4 is the wrong answer. Next, earth magnetic poles coincide with the geographic poles. So if you consider, suppose here it is North Pole and here it is South Pole. Next, if you consider the geomagnetic meridian, mostly those line, okay, so those lines are just like this. North and South Pole are not coincide, so it always maintains certain angle. So that's why this option is also wrong. Next, the net magnetic flux through any closed surface is 0. Here it is the closed surface. So if you consider net magnetic flux according to Gauss law, so here we get 0. Na? That's why option B is the option 2 is the right answer. Next, two magnetic field lines may intersect. So if you observed in this picture, mostly there is no intersecting. Na? Okay, so there is no intersecting of any two lines. So due to that, here we have to consider option 2 is the right answer. It's next one. Parsec is a unit of. Parsec is unit of acceleration, speed, length, and time. So here it is one of the interesting phenomena. So if you consider parsec, 1 parsec is equal to 3.26 light years. Light years. Next, 1 light year is equal to 1 light year is equal to 9.45 into 10 power 12 kilometers. Next, 1 astronomical unit is equal to 150 million kilometers. Million kilometers. These are all considered as units of distance. Units of distance. So that's why we have to consider length here. Okay, so option 3 is the right answer. So which is the largest unit of distance? Nothing but parsec. This is the largest unit. Largest unit. Largest unit of distance. And which is the smallest unit of distance? Nothing but smallest unit. Smallest unit is considered like Fermi. Okay, 1 Fermi is equal to 10 power minus 15 meters. 10 power minus 15 meters. So this is the smallest unit of distance. Okay, so you have to remember longest and smallest unit of distances here. So next one. So here the correct option is option 3. What about time? Which is the largest unit? The largest unit of time is galactic year. galactic year. It means 225 to 250 million years. 250 million years. Next, smallest unit, Jepto. Jepto second. 10 power minus 21 seconds is considered as Jepto seconds. This is the smallest unit of time. Okay, so these are the concepts especially for parsec. And the next one is Weber per second is equivalent to Weber per second. Weber per second is equivalent to, so ohm, volt, ampere, coulomb. Of course, here it is the right answer, volt. So Weber per second is equal to volt, nothing but it is also considered like the unit of magnetic flux. Actually, Weber is considered as unit of magnetic flux. Okay, you have to remember what are the units of magnetic flux, Weber, and what are the units of okay, so what are the units of units which is equivalent to Weber per second, nothing but volt. Of course, ohm. Ohm is unit for resistance, na? Resistance, ampere, flow of current, coulomb, charge, units of charge. So these are the units of different constituents. Next one, which of the following is the SI unit of measuring the amount of substance? Okay, SI unit for measuring the amount of substance. So we have to consider mole. So 1 mole is equal to, actually this mole concept was proposed by Avogadro, na? So Avogadro number it's symbolically indicated like this, Na, which is equal to 1 mole. 1 mole is equal to gram equivalent weight, okay, which is equal to especially considered like 6.023 into 10 power 23, which is equal to 22.4 liters. 22.4 liters. Okay, so this is the relation. So here we have to consider option 1 is the right answer. What about candela, Kelvin, and meter? So candela is nothing but SI unit of intensity of light. Next, kilogram. Okay, so mass. So this is the unit of SI unit of mass. Next, what about we already discussed it, na? Next, what about time? Second. Next, electric current, ampere. Next, distance, meter. Next, temperature, Kelvin. Okay, so you have to remember the SI unit of temperature, that is nothing but Kelvin. So these are the concept which concerns to the remaining options. Right. So next one is, what is the boiling point at standard atmospheric pressure at sea level and 45 degrees latitude of water on the Celsius scale? Okay, suppose, so what did they mention? What is the boiling point at standard atmospheric pressure at sea level? Okay, so boiling point at sea level, nothing but it concerns to water, na? And here they mention 45 degrees latitude of water on the Celsius scale. Okay, degree Celsius scale. So water, if you consider water, its boiling point is 100 degrees centigrade. 100 degrees centigrade. So that's why we have to consider option 2 is the right answer. Next, if you consider water, its freezing point is 0 degrees centigrade, and water exhibit maximum density at 4 degrees centigrade. Okay, so maximum density at 4 degrees centigrade, maximum density, and lowest volume at 4 degrees centigrade. Yes, so at the same time, you should also remember the relation between degrees centigrade by 100 is equal to, okay, so in Fahrenheit, F minus 32 by 180, which is equal to K minus 273 by 100. Okay, this relation is also very important. Okay, so mostly they will raise few questions on this relation. Suppose if they mention the boiling point of water is 100 degrees centigrade, so you have to convert into Kelvins or Fahrenheit like that. Okay, so that's why you have to remember this relation. Okay, yes, next one. A fuse protect an electric circuit from. A fuse protect an electric circuit from, here they mentioned, inducing current, overloading, carrying current, converting one form of energy into other. So which is the correct option here? Yes, yes guys, which is the correct option here? A fuse protect an electric circuit from overloading. If you are getting high voltage current, mostly mostly electronic gadgets mostly be destroyed na. So to overcome this type of phenomena, we have to use one of the electric gadget, that is nothing but electric device, that is nothing but a fuse wire. Okay, so fuse. If you consider ideal fuse wire, it is always made up with solder. So this is one of the Li. Solder means it is having lead plus tin. Solder is nothing but it is having lead plus tin derivative. Okay, yes. So that's why we have to consider option 2 is the right answer. And what is the major importance of this ideal fuse wire, or what are the unique characteristics of ideal fuse wire? Mostly, if you are using ideal fuse wire, it is having high resistance and low melting point. So because of that, we have to use this materialized ideal fuse wire. Okay, so next one, which one of the following is characteristic of conservative force? Characteristic of conservative force. Okay, so work done by it in a round trip is not zero. Here they mention not zero, so that's why it is considered like absolutely wrong. Next, energy is dissipated as heat energy. Okay, so this is also not considered. Okay, so this is also not considered as the characteristic of conservative force. And work done by it depends upon the path. Actually, work done actually depends upon the angle, na? So W is equal to Fs cos theta. We already know this equation. So next, work done by it's completely recoverable. Okay, work done by it is completely recoverable. Here they are rising about a characteristic of conservative force, na? So that's why we have to consider option 4 is the right answer. Work done by it is completely conservable. Next one, in a medicine, dash is a device such as a small metal plate or needle that carries electricity from an instrument to a patient for treatment or surgery. So what kind of mostly device is being used for a metal plate or needle that carries electricity? So here, so you can easily identify the correct option. So option 2 is the right answer, electrode. So mostly to pass electricity, we have to use electrodes, na? So this type of devices mostly be used. So that's why we have to consider option 2 is the right answer. Next, machmeter. Of course, you know that by using this machmeter, we can identify the object speed, and it always compared with the always compared with the velocity of sound in air. Okay, so what I'm saying is Mach number is equal to velocity of an object by velocity of an object by velocity of sound in air. Velocity of sound in air. Okay, next, so venturimeter. So option 3, venturimeter. Actually, this meter is used to measure the volume flow rate in volume rate of fluids, especially in a pipe. Okay, so what I'm saying is, by using this venturimeter, what we where would we use to measure the flow rate of fluids, especially in a pipe? Okay, so this is about option 3, and an electrolyte. So what is meant by electrolyte? Suppose if you consider few materials, so it does not allow the electrical energy, na? So few materials allow the electrical energy, few materials does not allow the electrical energy. So which materials allow the electrical energy? That is considered under the category of electrolyte. Okay, electrolyte means it allows the electrical energy. Okay, electrical energy. So that is the meaning of this terminology. So here the correct option is option 2, electrode. Next one is all the non-zero vectors are called. Actually, we have different types of vectors. So all non-zero vectors is always considered like a proper vector. Okay, option 4 is the right answer. After, so 4 is the right answer, proper vector. Next, which of the following statement is correct? Which of the following statement is correct? So frequency of, they mentioned about correct statement. Frequency of wave is the number of oscillations of each constituent particle in the vibrating medium per minute. Okay, so per minute they mention. So frequency of wave is the number of oscillations, so per second. But here they mentioned the minute, so that's why it is considered like wrong. Next, the minimum distance between 2 points in a wave having the same phase at particular instant of time is called as wavelength. Okay, yes, of course this is absolutely correct. So that's why we have to consider option 2 is the right answer. Okay, what did they mention? Suppose if you consider a wave, actually in a wave it is having crested trough like this. This is the maximum displacement. So this is nothing but anti-node, and here it is node, and this one is anti-node, and this is node. This is also considered like anti-node. So the minimum distance between 2 points in a wave. So this is the minimum distance between 2 points in a wave having the same phase. Okay, so these two are having the same phase like this, same phase like this. Okay, yes. At a particular instant of time is called as wavelength. So this is nothing but lambda. So it is symbolically considered like wavelength. So that's why we have to consider option 2 is the right answer. What about the remaining one? If the constituents of the medium oscillate perpendicular to the direction wave propagation, we call the longitudinal waves. So if you consider longitudinal waves, here applied force is directly proportional to the generated waves. But here they mention perpendicular. So perpendicular, so that's why this terminology was wrong. Next, if the constituent of the medium oscillates along the direction wave propagation, we call the wave transverse wave. Okay, so transverse wave, here they mention along the direction. Along the direction means, so force and generated waves both are in the same direction. So to get transverse waves, here force and wave generated waves both are perpendicular. So that's why here this option is also wrong, because here it does not maintain along the direction. That is the wrong option here. So that's why we have to consider option 2 is the right answer. Next, the lowest temperature at which substance catches fire is called ignition temperature, normal temperature, boiling point, and melting point. Option 1 is the right answer. Why? Because the lowest temperature at which substance catches the fire. Okay, so suppose if you consider diesel and petrol, in these two things, which one can easily catch the fire, or which one is having highest ignition power? So it depends upon the nature of the chemical. Okay, so the efficiency of petrol indicates in the terminology of octane number. The efficiency of diesel indicates in the terminology of C10 number. Okay, so C10 number indicates the ignition capability. Okay, ignition capability means by using less temperature. Okay, so by using low temperature or lowest temperature, so some of the materials can easily catches the fire. So that's why we have to consider option 1 is the right answer, ignition temperature. So this is the meaning of the terminology, right? So boiling point, we already know that the temperature which is required to convert liquid into gas. Next, melting point. Melting point means the temperature which is required to convert solid into liquid. Okay, so next one. So coulomb per second is equivalent to coulomb per second. We already know that flow of current. Actually, flow of current indicates with I na. So I is equal to charge per time. Flow of current is equal to charge per time. So here charge is equal to charge. What are the units of charge? Coulombs. Next, what are the units of time? Seconds. So coulomb per second is nothing but ampere. Coulomb per second is nothing but ampere. So that's why we have to consider 1 is the right answer. Next, ohm is units for resistance. So of course volt. So volt are units for potential difference like that. Na? Okay, so potential difference. Next one, joule. So it is units for energy. energy, work, whatever it is, almost we considered the same type of terminology. Next, in terms of SI prefixes, 10 power minus 15 is called. So 10 power minus 15 is considered like femto. Okay, so 10 power minus 15 meters. Femto means like that. Jepto means 10 power minus 21 meters. Atto means 10 power minus 18 meters. Next, acto means 10 power minus yes. So like that. Okay. So here it is different concepts now. Next one. Dash is used to measure the pressure inside the eyes of a person. Measure the pressure inside the eyes of a person. So tonometer, viscometer, odometer, machmeter. So option 1 is the right answer, tonometer. So this is the tonometer. By using this meter, we can identify, we can measure the pressure inside the eyes of a person. Next, what about viscometer? So this is viscometer. By using this one, we can identify or we can measure the viscosity. Okay, viscosity of fluids. Next, odometer. So this is nothing but odometer. By using this meter, we can measure the distance traveled by the vehicle. Okay, so mostly in vehicles we observe this type of meters, na? So it is used to measure the distance traveled by vehicles. So last one, Mach number, we already know that by using this Mach number we can estimate or we can measure the object velocity, and it is also compared with the velocity of sound in air. So these are the concepts about remaining options. Yes. So this is the final concept about all the questions which were mentioned in these sections. Okay. So you have to prepare. Of course, you have a better idea about physics related questions, especially in CGL, SSC CGL Tier 1. Okay. So you have to prepare only basic concepts. So if you observed these previous year's questions, mostly they raised about units of some of the formulas and vector and scalar quantity. Okay, and next one, work related and power related formulas. Next one next one, some of the statements, which one is correct and which one is wrong. And next one, magnetic field related questions and electric field related questions. Okay, next, gravity based related questions. Next, some of the units. Okay, so mostly they mention very simple type of questions, na? So you are getting almost same kind of orientation in this 2023 CGL SSC CGL Tier 1 examination also. So that's why you have to focus on NCERT textbook from 6th to 10th class only on basic concepts. Okay, so this is the final conclusion about today's section. So by the way, I'm Lankeshwar, General Science and Science and Technology faculty. Thank you.